Hey everybody, it's Tyler here at the Purdue SIGBOT Slam and Jam VEXU event, checking in with Ghost from UT Austin. I love this machine, or set of machines really. A lot of great stuff to go into. I think really the key star, hopefully you see it spinning around there, is that LIDAR that they're using. So we'll be showing off how that localization works for that, but a lot of great other things that go into these pairs of robots. You gotta check out their motor stack, by the way, how they're running that. Maybe some feature plans to talk about too. And we'll be doing more of an overview on these robots, going up from their intake all the way through, and really diving more into what goes into these machines and a little bit more on their code as well too. Let's learn more about them coming up here on Pits and Parts. Joseph, let's start to break down this robot here, talking about this motor cluster, how this all comes together. I really like your gearing as well too, so let's dive more into that and maybe some future plans for this robot.
Okay, so this is a modular motor cluster here. It is modular, of course. These blocks are stacked up here, and we just tile these gears along here. So this gear ratio here is adjustable, and so is a lot of the spacing and stuff here. And because it's stackable, we can really just add as many of these as we want up here. So you never know, we might soon have more on top of this.
So when you were looking at designing, I mean, I love the packaging in this, right? So when you were coming up with this design, at what point were you like, hey, this is a necessity for us to kind of move these over, versus so many other teams where it's just, motors on the bottom or something like that? Tell me more about that design process.
So we really wanted to have a lot of space in between here for, moving rings around and stuff like that. So we needed a way to move the motors to some other area. So we figured, what's the closest area to the wheels where motors will fit, and it's pretty much right above them. And it was kind of a challenge at first to fit them here, but we figured it out eventually, and it fits pretty well.
Yeah, I love it overall. I think it's a great package set you have in there. Let's talk more about some other aspects of this robot here. Pass over to Max, talk about the intake system. And then on your gold clamp as well too. Like, this is really cool, this whole design, and we'll dive more into how all that really came together, and of course how it functions as well.
Yeah, awesome. So I'm gonna go start with the front intake. So the first notable thing we have here is we have a color sensor that's going into our Jetson over I2C. So when we grab a ring, we can detect like whether it's red or blue pretty easily, both during Auton and driver. And then based on that, we can auto reject it for rings that are red versus blue. So this would be a normal score. Yeah, the auto reject, then we can do like this, and you can see the hooks will stop here at the top. And so that feeds it over into our mobile gold clamp, which we've been calling the rotationally invariant mobile gold clamp. So the thing about this is basically we took the mobile gold in CAD and we revolved it and we like swept it through. So we have this single like rotationally symmetric object, and then we molded it around that. And so no matter how you grab it, whether it's on this flat face or up against this corner, it will always basically put this in the same spot. So if we grab it here, you can kind of rotate it through, and you can see that this is always in the same spot. And that's one of the things that's contributed to our intake being more consistent on scoring the hooks and such. And I guess the last part is, along with that auto rejection, we also have it to where it'll reset the hook position whenever it's back to idling on the ground, so that it's always ready to grab the next one.
How did you actually do the molding for that itself? Like, did you do a scan of it, or did you straight up just design it? Like, how did that mold actually come?
Yeah, that's a great question. I guess when I say mold, we took the CAD model of the mobile goal and we split it along two different planes, and then we kind of projected those into one sketch. And so for like the corner, it sticks out farther along the outer diameter, and then for these flat planes, it sticks out. It's more present in the inner diameter. And so then we like revolved both of those. So in our CAD, we have like a model of a mobile goal that is perfectly circular.
Oh, that's
and
really
then
cool.
Yeah, then we literally like use that to build the profile of this before we revolve it through, and then we 3D print it.
That makes perfect sense on that. Melissa, we really got to dive into this LIDAR that you're doing here. Obviously a big star, I think, of these robots as well too. So just talking about like, how your team is actually benefiting from it, and then of course we'll dive a bit more into what some of this looks like as well too.
All right, so I think most VEX robots use like wheel encoders, maybe an IMU to localize their robot, which can be good, but like, especially during an Auton, if your robot runs into something, your odometry is immediately confused, your robot doesn't know where you are. So that's a big challenge we wanted to address. And I think you'll notice the spinning thing, which is a LIDAR, and it's similar to like how sonar operates, but instead of sound waves, it uses light. So we use that data in addition to the wheel encoder data and the IMU data. And it all gets fed into our second processor, which is not the brain, but a Jetson Orin, which is like somewhere deep inside. And so that all gets fused using an extended Kalman filter, in addition to utilizing the LiDAR data via a particle filter. So yeah, this all comes together to make a really good, robust localization stack. It works so well that at one point, our gear ratios were accidentally doubled. And it still worked fine, even though the odometry was
I want to ask
whack.
you from utilizing localization, is that something you're solely using autonomous, or are there ways you can do like auto alignments or anything like that in teleop as well?
It shines in autonomous, but we used this localization stack last year as well. And you can implement different types of like driver modes so that it's easier to program and for the drivers to use. And we relied on that field-oriented control last year, but that's not really applicable for this year. So yeah.
Yeah, absolutely. Let's start wrap up on this robot, Jake. Let's bring in talk about the auto stack and behavior tree that you're utilizing for that. I know we're going to show a couple things on your computer as well too, but like, overall, this is just such an impressive machine. Walk me through more of what you're doing on this front.
Yeah, so thanks to Melissa's hard work with our localization stack, our robot knows exactly where it is pretty much 99% of the time. So using that, it's very easy to get the robot to go exactly where we want it to, whenever we want to. So we have different algorithms which calculate paths, such as like a Bezier curve or like a boomerang planner. And with that, just gives us a list of points that we feed into our pure pursuit controller, which allows us to sort of go anywhere we want on the field, just given an end goal and in like angle position. So we use this in the behavior tree, and we like chain all these steps together, along with different nodes that we've created for like intake commands and similar things like that for different parts of our robot. And so it allows us to easily sequence exactly how we want our autonomous routines to run. And so it makes it very consistent once we actually are able to tune all the numbers and everything.
So on pure pursuit as well too, are you just have like field mapped out and you're just clicking and dragging autonomous modes, or what are you doing exactly for that?
Right now we just tune it by numbers, so we just say we have it tuned to where we put in like how many. We have our bottom left corner of the field as our 0, and we just tell it how many tiles over in each direction, and then like an angle that we want it to go for each position.
Are you having to do any like from event to event? Do you have to tweak that a little bit to kind of compensate for any field tile variances or anything
Usually
like that?
we don't have to. The only issues we ever have is just like more mechanical. If something's like slightly different, sometimes it doesn't always work exactly how you want it to. But with a quick adjustment, everything always works pretty smoothly.
Typical programmer blames the mechanical team. I get it.
Yeah,
Definitely. Hey, overall, Ghost, this is a really cool robot inside the machine. So thank you so much for telling us more about what's gone into these. I think there's a lot of great inspiration out of this. So we can't wait to see, of course, how you continue to do it. But really appreciate you breaking down these robots for us. And wish you best of luck the rest of the way. Thanks a lot.